It's this. All right, so before we get into things, anybody have open questions, general questions? We had homework 1 due on Monday, homework 2's out, you're starting project team meetings this week. Don't forget to submit your project team meeting form. What do I call them? Meeting form, I'll just call it. Don't forget to submit those starting this week. Any questions about any logistics or anything? Yeah. Yeah, I don't care when you meet. Yeah, if you want to meet on, so it's on the video, yeah, you can meet on weekends or whenever, as long as you're meeting once a week, at least once a week, and filling out the forms. But you do have to meet every week. It is, so those team meetings are replacing your recitation sections, so those do have to happen officially, or else the university gets mad at me and says, this isn't a 4-credit class, it's a 3-credit class because you don't actually have recitations. So to justify that, those are your recitations. Yes? No, yeah, it can be whenever you want. You can schedule it whenever you want, but you do have to have one each week. But if you do want it during your recitation, the nice thing about that is whenever your recitation is, you know that room's going to be empty. And if somebody's in there, you can say, hey, this is reserved for 312, get out. So you do know that you have those spots on campus if you know, whether you're meeting there or not, if you just want an hour to go study someplace where you know it's going to be available, because it's hard to find a spot in the library. How do I get this off my screen?
F11. No.
F11. Well, I can't even figure out how to get this screen blank. Like, if I put something there, it's there forever. I don't know how to do anything else. I'm just going to look at it all lecture, I guess. Oh, no, I have the mouse right here, don't I? Alt F4, yes. There we go. All right, any other questions? Yes? That's not related to the 312. Yes, though. It'll be in O'Brien 5. I did kill Produce Pun. Okay, I just want to make sure to sit on that for a second. Make sure there are no open questions before I just go into lecture mode. Let's get this stuff out there. Not found. If you get not found, just refresh it. Oh, there it is. If anybody's wondering, I guess since this is 312 and we're talking web apps, I can explain what just happened there. I changed the file name for the PDF, but I had the page loaded from before, so the link was for the old file name. I had to refresh, get the link to the new file name, and then access the new file. But it's because I changed the file name of that PDF. So let's talk about buffers. Who's ready for buffers? Oh, actually, there was one more thing I want to make sure I did before this. So I've been trying to do regularly. Every time, I'm glad they finally have pageless format, so there's not page breaks in the document. But every time I'll go to the same document, it'll keep telling me about it. I get it, Google, I get it. So right now you can do Objective 1, your first HTML template. We learned about templating last time. You have everything you need to do this. You take the text form submissions. Now, there is a lot involved here, don't get me wrong, but you have everything you need to do this. You have the text form submissions, where you just don't attach a file to the form submission. Parse the multi-part requests. Store that in a database. Did I require databases for this? No, I didn't. So you don't have to... Oh, because, yeah, Objective 4. I'm like, I know I did, but I split it across objectives. So you can store it in a data structure, I guess, for this one, database later on, and then serve that to all your users. So you need to have your HTML template with some way to loop over the data and generate HTML for each piece of data that was submitted. For this one, just the text, just the comments or captions for the images without the images themselves. So we have everything we need to do this. You can get started on Objective 1. You could be done with Objective 1 by now. Some of you might be. But you can start. If you haven't started the homework, there's nothing stopping you from doing Objective 1 and mostly Objective 2. I'll talk about this by the end of the lecture. You'll understand what I mean by that. But you can add files, you can start uploading files through that form. You can parse all of the multi-part form request stuff like we talked about, making sure that you never convert that image into a string. And then extracting the bytes of the image, saving them to disk, and then serving all of those images to your users. We can do all of that except one caveat, which we'll talk about today. And also today, we'll learn how to serve large images. By the end of today, you'll be able to do objectives 1, 2, and 3. And I believe there's nothing new for 4, right? This is just throwing all that stuff in a database. We've known how to do databases since homework 1. So objectives 1 through 4 you can do after today's lecture. And then 5 we'll have to wait till we talk about cross-site request forgery tokens. But 1 through 4 after today's lecture. So let's talk about buffers. So we're going to get requests in this format. We've talked all about parsing this format. I'm not going to talk about parsing the format anymore. But I do want to talk about some implications of this. We have a TCP socket. We have TCP connections. We use TCP to create a persistent connection over IP and a reliable connection over IP. And whenever we get data over that connection, we're going to do something to read some bytes off of that two-way communication stream, and stream being the important word there. In Python, we're calling receive. In JavaScript, we're giving a callback function whenever data is received, and then JavaScript calls this function using an event-based architecture whenever data is ready on any sockets. So we're going to read this, we receive the data, and we're going to get all of this data as bytes, and then parse it and do what we will with it. TCP is a persistent stream of bytes. So you do your three-way TCP handshake, which the library is doing for us no matter what language you're using. Your library is doing the three-way handshake. That establishes a connection between two peers, in our case, a client and a server. And then both client and server can send bytes over this stream at will, back and forth. For HTTP, the client says, hey, let's connect. We do the three-way handshake. The client says, here's my HTTP request. And then we say, here's your HTTP response. And then we sever the connection, and they create a new connection if they want to send another HTTP request. There are ways to reuse the same connection. If you see keep alive headers, that's what that's doing. Your server can just close the connection. The browser will create another one. We don't have to worry about that quite yet. Maybe someday that'll be part of this course, but it's not super interesting. It's just an efficiency thing, not a how do things work thing. So I'm not too concerned. But it's a stream of data over a persistent connection. For homework 1, all of the requests are designed in such a way that you don't have to think about this. So with your small GET requests, you say, socket, give me some bytes. And the socket says, here's your entire HTTP request. Knock yourself out. And then you process it and send your HTTP response, and everything's fine. Homework 2, everything won't be fine. Yeah.
If you're just using like Postman, is it still setting up the TCP sockets even though it's on the same computer?
Yeah. Mm-hmm. Yeah, even when you connect to localhost, even when it's Postman, no matter what, it's TCP. In your code, that's all you coded was a TCP server, and then you built HTTP on top of that. So to talk to your code, it has to be a TCP connection. Yeah, HTTP is everything that you wrote. So you're implementing HTTP, but you're just starting with a TCP connection, a TCP server. So if anybody wants to talk to your HTTP code, they must establish a TCP connection first. Even when it's a browser on your own laptop, it still has to establish a TCP connection. Is Stefan Diggs here? I want an autograph. I don't see him. Somebody in chat said he is. So what happens when we get big requests? Now that we support file uploads for homework 2, we're going to get big requests. Now, in the Python code, this is a little more clear. You're going to receive 2K bytes of data. That's going to be the buffer size of your TCP buffer size. What this means, and I'll explain this more the next slide, but what this means is you're going to receive at most 2K bytes of data off of the TCP stream. So if somebody's sending you a bunch of data, you're going to say, give me at most 2K bytes of data that's ready to be read. And this request is 91K, or 91,000, I should say, bytes of data. Just in the body, not including the headers, so a little bit more than that. Well, I'm not going to get the full request in a single read anymore. Homework 1's designed so you always get the entire HTTP request in one read from the socket. But homework 2, that will not be the case. And what if it's even bigger? So we must read from the socket multiple times. And the TLDR of it is you're going to call receive multiple times. You're going to get multiple, you're going to say, hey, I didn't get everything. Give me another 2K. Okay, that wasn't it. Give me another 2K. Give me another 2K. And you're going to do that until you have all of the data. Same thing for JavaScript. It's a little different, but JavaScript is going to call your callback whenever there's data ready to be read. So if that buffer, which I believe is 64K, it's hard-coded into the library. I believe you can change it, but there's no need to. So every 64K, it's going to say, here's 64K, here's another 64K, here's another 64K, here's another 64K. And it'll do that until there's no more data to be read off the socket. Yeah?
So is it recommended that we find the size of the actual data through the length function, for example, or
Nope.
should we do kind of a remainder like the percentage 2048 and find the number of times we call that number?
The second one. So, and I'll explicitly, by the end of this lecture, I'll explicitly say not to do the first one. So do not just increase this number. Like we could increase this number to 2 million and just read this whole thing in one go. No, not allowed. What we're going to do is buffering instead. Because first of all, what number would you even choose where you're sure that it's larger than any request you're going to get? And two, there's still issues with that we'll see, where sometimes the browser will chop up the request and only send some of it chunks of it at a time. So multiple issues with that. So you're going to read bytes from your socket. User sends you some information. You read that information, you process it, you send a response. Everything's fine. What happens when the user sends you a lot of information and you can only read one chunk of it at a time? This is what we need to think about moving forward. And this can happen for a lot of different reasons. What if somebody's sending a request, uploading a really big file, a really big image to your website, and in the middle of that upload process, their ISP has a hiccup, and there's a gap in time, and then the rest of it sends. Something very common that'll happen. You get a bunch of the data, and then nothing happens for a while. If you're sloppy with your code, you might think, they're done sending us anything, so let's go ahead and process this. But you don't actually have everything. Well, after the hiccup, then you get the rest of the data. A lot of things can happen. Or what happens if you're streaming video? What happens if you're downloading a stream? Now, the way most streams do work, this wouldn't actually be the case. But you could set up a persistent connection and just keep continuously streaming video over that connection, over a TCP connection. In practice, that doesn't really happen because there's so many issues with that, namely, what we're talking about right here. But there can be a lot of situations where you're getting a lot of data, sometimes slowly, over a TCP connection. So you're going to have to read from the socket more than once. So when you have those buffer sizes, like in Python, you're going to read at most that many bytes. Keep this in mind when you're writing your code. You're reading at most that many bytes. I said in my Python, my buffer is 2K, so I'm going to get at most 2K bytes, but I might not get 2K bytes. One, if the message just isn't 2K bytes. Of course, I'm not going to get enough. the full 2K. But sometimes, even if you have like a megabyte file that's being uploaded, each time you read from the socket, you might not get the full 2K at a time. There are a lot of reasons why that can happen, namely like the internet hiccup and other things that we saw in the previous slide. There are a lot of ways that can happen. So the second one that you mentioned there, where you take the number of bytes you expect and divide it by your buffer size and read that many times, that won't always work because you won't always get the full buffer size when you read from the buffer. Now, most times you will, especially when the browser is on the same laptop as your server, but you can't do that reliably. And for homework 1, it was a safe assumption that you can read the entire thing in one go. So we didn't worry about it in homework 1, purposely because I didn't want to talk about buffers in homework 1. Yeah.
Is the buffer size at most limit, is that a security thing where you don't want somebody tying up the server, sending like a crazy NASA photo?
It's more of a performance thing. So if it's too high, it might just be, I don't know. I don't have a better answer than that, but it's more of a performance thing. So now we do have to think about these buffers. We didn't have to think about it for homework 1, but we do have to think about it for homework 2, starting with objective 2, depending on certain circumstances. So we got to start thinking about this. So we're going to have to call, I kind of got ahead of my slides here. I got excited on the first slide. But we've got to call our receive method multiple times, whatever library it is. You're either going to have, I only showed JavaScript and Python, and in my demos I only show JavaScript and Python. But whatever language you have should follow one of those two approaches, either JavaScript's event-based architecture or Python, where it has you access the socket directly and ask for a certain number of bytes, up to a certain number of bytes. Any language I've seen, at least used in this class, has followed one of those two architectures. So one of those two should apply to whatever language you're using. And you're going to have to either call the receive method multiple times, or the callback that you provide is going to be called multiple times. So here's our strategy. Here's what we want to do when we're receiving a large request. So starting with kind of objective 2, but definitely objective 3, is we want to read from the socket. That's number 1, of course. That's what we've been doing since day 1 in this course. We want to read bytes from the socket. You're allowed to assume in this course that first time you read from the socket, you're going to read all of the headers. Every header value is going to be contained in there. So you can just assume that you do have that, which is an assumption I could remove. Well, it'd be pointless though. But you're going to read, you will read, you can check this by making sure that you read a /r/n/r/n. If you read that byte sequence, then you know that you have all the headers. But you can just assume, that's a safe assumption in this course, that you received all the headers in the first read from the socket, which includes content length. You're going to read the content length header, get the number of bytes that you're expecting in the body of the request, everything after that, /r/n/r/n, everything after that, that's going to be the number of bytes. That's stored in the content length. And then make sure you read that many bytes. So this is the strategy that I strongly recommend. I don't even know what else you would do. But keep calling receive, not for a specific fixed number of times, not with any calculated, pre-calculated, anything. Don't increase the buffer size to the content length. Don't do any of that. But instead, read from the TCP socket until you've read content length number of bytes. So this should be a while loop. While length of my byte array for the body of this request less than content length read from the socket. Yeah.
Wait, so content length determines the size of the body?
Yeah, just like when you send responses. Right?
What if you've already read part of the body then, but there's still like one?
Make sure you track that. Write code to track that.
Okay.
Yep.
So
No, you can't. After you've read the headers. Oh wait, yeah, you can assume that. Yeah, what am I saying? The first time you receive, you might get part of the body though, so you have to take that into account. But yeah, after you read the headers, you can. I mean, you can kind of assume that it's all going to be body, but you have to be careful. Like once you read content length number of bytes, the next time you read from that socket should be the next request, or you close that socket and force them to create another socket. But it could be the headers for the next request.
So the case when we have, for example, like thousands of headers in a request, then it might be the case that the next time we call, there is a part of headers in the next call as well.
In this course, you can assume that that's not the case. You can assume that you've read all the headers in the first receive. So in Python, as long as you have a 2K buffer, that should always be the case for our purposes. Sometimes that's not true, like when a specific server sets like ridiculously large cookies, which are stored in headers. That might not be the case sometimes, but your server shouldn't be setting ridiculous cookies, so you should be good. But if you don't read all the headers, you look for that CRLF, and if you don't find it, read again, and you're still reading headers. Would be the solution to that. And to go one step further, this is why servers and browsers have a limit to the total length of the headers, is to prevent issues like this, where we want to make sure we get to the end of the headers quickly so we can start processing the requests and figure out what this request is for. So they usually have limits up to like 16K, I want to say, would be the most generous servers and browsers. So we won't have too large of headers. Yeah.
Is that the reason why if you send a response to the browser and the content length is higher than what you're sending, why it just won't read it at all? Because it's waiting for the last of it?
Yeah. Yeah, because the code on the browser is going to look just like the code you're going to write on homework 2. They're going to have a while loop and say, well, I haven't read the content length number of bytes yet. Keep reading from the socket. And if there's no more bytes there because your content length was longer than the number of bytes that you sent in the body, it's just going to hang in that loop until it times out. And then process the request. We've been doing that since Objective 1 of Homework 1. Whatever the request is for, in this case, an image upload, save the image to a file, parse the multi-part stuff, take the comment, save that comment in a database along with the file name where you save the file, and then respond with the 300 level redirect. So the assumptions, just to keep the complexity just a little bit down, because there are really strange situations that can happen in these. You can assume only one user will be uploading a file at a given time. So if you're buffering and you're reading bytes and you have this buffer, you can assume that that buffer is for one specific user and that you're not going to worry about reading 2 files simultaneously, and you're not going to worry about reading the headers, like I kind of mentioned not too long ago, the headers of the next request. You don't have to worry about that either. You can just assume if you're buffering, there's just one file being uploaded, and that's the only thing your server is doing at that time. We're going to break that assumption in Homework 3. You're going to have to handle multiple simultaneous connections. When we have persistent WebSocket connections, multiple users having these connections, we have to make sure we're multi-threaded or at least concurrent, which admittedly isn't too hard, at least in Python and JavaScript. The first read, I said this a bunch of times, but the first read will contain all the headers. You can assume that. So you can assume you can read once, then parse the content length, and then decide if you're buffering or not after that. So you don't have to buffer the headers themselves. And you can assume that we're going to look through your code while we're grading and make sure you didn't do anything silly like this. You have to actually buffer. It's something I'm explaining in decent detail in lecture. It's something I expect you to code up. I'm not just saying this just for the fun of it, and then you just jack up your buffer size there. That's a no-go. That doesn't work. The TAs are going to look through that when grading. I'm pretty sure I added it to the testing procedures explicitly that we're going to check and make sure you didn't do this. Yeah?
Is the body still separated from the headers by the /r/?
Yep. Yeah, it's still an HTTP request. It follows that same format exactly. So when you're parsing these things, when you're buffering, your request is still going to be exactly like this. There's just going to be a lot of bytes here. But all the format's exactly the same. Questions before we get into demos? No, I don't want to update right now. VS Code. This one. All right. Start with Python. Servers. Why did it change my directory? I was already in the Python directory. So I have another server here. This one's even more basic than the first one I had, as it turns out. But I just want to show off some buffering stuff. So this server, I'm going to hit it with a well true. Please don't do this in your code. I'm always surprised at how many times in office hours the TAs and I will see my lecture code exactly character for character. And then the student says, why doesn't this work? It's exactly what was in lecture. It's because I'm not showing you homework solutions. But well true, and this one I do have a note just to make sure. This will be where you say, well, content length greater than the length of the byte array that I'm reading for the body. Number of bytes I read from the body. It's up to you to figure out exactly how to set that up. But this is just going to consistently read. I'm always going to read from the TCP stream. And you can, if that wasn't clear from this lecture, you can call this more than once. I'm calling it, forever. But you can just call this method multiple times and keep reading from the same TCP stream. For homework 1, we just read once and assume that we got the entire request, which is a safe assumption in homework 1, and then process the request, send the response, and then we're done with that TCP connection. Once we hit the end of this handle method, our library is going to sever that TCP connection, tell the client that, hey, we're done, we're closing this connection, and if they want to make another request, like for the CSS, they create another TCP connection, another three-way handshake. This method is called again for the new connection. We read once, we send once, and then sever that connection. That's what this method is doing. So if we want to read more than once from the same TCP connection, we can call this method more than once. Now, if there are not bytes to be read, this might just hang. Or sometimes, which is why I have this next line, sometimes it will read 0 bytes. I don't know why, but if you're seeing that in your code when you're testing, just add a line like this. If I didn't receive any bytes, don't do anything. I don't know why this happens sometimes. It shouldn't happen, but sometimes it does. We're going to say, if we didn't actually read anything, don't do anything. But if we read more than 0 bytes, I'm going to print out the client ID to the screen. The address of 0 is going to be the host, and address of 1 here is going to be the port. This isn't particularly useful, but I think it's interesting, so I'm going to print that to the screen. It's not particularly useful in your homework yet, not until, is it ever for homework 3? Maybe not. Maybe it won't be. But it is a way to uniquely identify a client. So if you have that use case, this is how we can do it. I'm going to print out the number of bytes that they're sending, and I'm going to print out the data that they sent. Importantly, I'm not decoding this because it won't decode because it's going to be images. And then printing out a new line and doing it again. Reading, printing, it's doing that forever. So let's run this. And also just to note, I don't ever send anything over this connection. So the browser, I expect it to just hang because it's going to be waiting for a response from its request. It's never going to get it, and it's just going to load forever and not do anything. That's not the part I want to talk about for this lecture, so that's not going to do anything. It's also not hosting any HTML, but I need some HTML here. So just kind of piecing together things that we know. You all know how to do this, but maybe haven't thought of this explicitly, so I want to show you. I have some HTML here that I'm going to open on my file system. I'm just going to open this file that was not hosted by my server. And it's going to open the file. It's going to have one form with, why is this formatted so bad? One form. It's going to be a multi-part form data post requests are going to be created, a text field for the name of the commenter, and a file that I'm going to name file upload, a file submission, and then a button that just says submit. And then it says hello world in blue down here. I forget why I put that, but I liked it, so I kept it. And then I'm going to open this file. I have it open, but I'll show you opening. I'm just going to go to Reveal in Finder, because I never know how to find it, and go to your HTML file. Stay with me here. Double-click it. Just opens it. So I'm opening the file. You've probably done that before. I shouldn't have been so dramatic about that. It'll open it with the file protocol. So this wasn't requested via HTTP or HTTPS or anything. It's using the file protocol. It just means I open this file from my hard drive. And I get to see my thing. And what I want to do, I didn't mention the most important part, the whole reason I went through all that. The action for my form. This is where you put the path that you want to, where you want to send this information, these requests, where you want them to go. I'm going to give it, instead of a relative path, I give it an absolute path. So I'm specifying the protocol. What happened to my slashes here? I know this works. I didn't remove the slashes. Should be 2 slashes here. The host, the port, and the path. So I'm specifying the complete URL. So now requests aren't going to be made to the same protocol host and port, which is file. Like, I don't want that being the protocol. So I'm going to give it an absolute path. And then requests for this form are going to end up going to my server because I specified localhost port 8000, where my server is running. I'm going to say Jesse. I'm not going to choose a file. I'm going to submit. And I'm going to see what I got. So my local IP 127.0.0.1 is localhost. I got port 50,555, a bunch of fives, that's nice, is my port. And it's sending about 1K, more than 1,000 bytes of data. Most of it's headers, but if we look close, we can see the end of the headers here. Nope, that's not the end of the headers. I lied. The end of the headers. We can see the first boundary, a new line, the headers for my first thing, the blank line, and then the value that I submitted for the commenter. A new line, the boundary again, headers, the blank line, no content because I didn't upload a file, then the new line, and then the boundary again. A trailing dash dash, and then everything after that last boundary dash dash. The browser's allowed to put whatever they want here. Opera decided to put a CRLF. You should ignore whatever's there. But the browser is allowed to put anything after the last boundary and before the first one. Usually they don't, but we do have a CRLF here, so just something to be aware of if that does end up causing a bug for you. But I read all this data in one go. Cool. Let's attach a file. I don't want to attach an image. I already have this sorted by size, and I'm going to submit my smallest file, style.css. See what we got. I actually didn't expect that. But this is the point I wanted to eventually make. It wasn't supposed to happen this early, but it does make my point. So 50,581 is sending 839 bytes of data. And we can see the last bytes that I got were the end of the headers. I didn't read any content of the body in my first read from the TCP socket. So even in Objective 2, where you're uploading small images, you can still need buffering, at least to some degree. So you might as well just jump right to Objective 3 and build your buffering system. So I didn't read any of the content, and then in the next read, I got 377 bytes, which should be exactly the content length, if we can find it in here. Content length 377. So the body in the next read from the buffer was exactly 377 bytes, and it's all the content of my CSS. Yeah.
Can you use the split command on bytes?
Yeah. In Python, yeah. It's not the same method, but byte arrays have a split method. I mean, you can look up the documentation on it. It's not what we're talking about right now. I had to read, but importantly, I had to read, well, let me get my server code up here. I had to call receive 2 times. So I got to the end of my loop, got back to the top, received more data by calling receive again, and got the rest of the data. So even though this could have fit in my 2K, both of these combined would have fit in my 2K, I still needed 2 calls to receive to be able to get this information. That's not always the case, and I didn't expect it to happen here. Usually Chrome does that. Chrome will do that whenever you upload a file. Opera usually doesn't. I want to submit this again and see if it does it the next time. Yeah, so Opera this time didn't. It put it all in one receive. I called receive once and got everything this time. So even within the same browser, you can get different behavior. I think it depends on how long reading the file from disk takes. If it doesn't want to wait for that, it'll send the headers because it can prepare the headers right away. And then after the file I/O is done, it'll send the rest of the request. So if the timing is just right, when you call receive the first time, you might, only the headers might be ready, and then you call receive again, and by then the file was ready, it was sent and everything. Now let's get to the interesting stuff. Let's send this little bunny, 11K. I can see all my bytes. It's not UTF-8, so it's not going to render anything the way I want it to. But we're going to see the first time we read, we're going to get all of the headers. We do get our CRLF, and our content length is about 11K. My file system had to round, but 1083 bytes, and then received 2K bytes, blah, 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 a bunch of stuff. At this point, I want to comment out printing the received data. Run this again, go back, submit, and piss off. Question? Did you have a question?
So, how is it different from the first object, the first hopper, except that now the Mac is sending the data version versus the server was sending the same size of file to the client, which was back.
Yeah, so the big difference from homework 1, you were sending large files in responses. The browser had to do this. So when the browser got your response, the browser had to buffer to get all your data. It had to do all of this stuff. But now, since the browser is sending us large requests, now we have to do the same thing.
So while sending your still use the buffer size?
In the browser? Wait, sorry, what was that?
So when we set up a server, we tell like 1024 or 2048. So is that the amount of data that is being sent to the client, or is it irrelevant?
No, when you do send all, like you're just saying send all this information, and your code, your library is going to send all of it, but then the browser is going to receive it in chunks. It's going to read it in chunks. So we can see we got 2K bytes of data. It's a roll of the dice what you're going to get. We got headers and body this time we can infer, and then we had to call multiple times to receive the rest of the data. And then the last receive is not going to be our full buffer. But some of those receives in the middle might not be our full buffer either. It's something you have to account for. Sometimes in the middle you'll get 500 bytes, whatever. But read until you've read content length number of bytes from the body of the request. I should wait for that to close gracefully. I think that's part of my problem there. So let's do the same thing in JavaScript. I have the same idea. On data, get the client ID, print out the client ID, the length of the data read, and then print the data to the screen, which if we don't toString, it just always shows the decimal values for the bytes of the characters, which I don't like. So I do toString. It doesn't decode properly. It just gives me garbled mess, but let's see what we get. Let's submit the rabbit again. So we'll get our garbled mess because these bytes aren't encoded using UTF-8. But we can see the same thing in JavaScript. So we received 11K bytes of data. So we have a much larger buffer size. Notice in JavaScript we don't specify a buffer size. We just specify a callback. Say, hey, whenever you got data for me, call this method or call this function. And then the library controls the buffer size. So we got 11K. Our content length is 10,000. Oh, we got the whole thing in one go, didn't we? And then all the bytes of the image, same format and everything. So let me get rid of this toString. Restart the server. And choose a bigger image, which I don't have in this directory. That one big enough. Let's go to 8 megabytes, a lecture PDF. Submit that. And we can see our buffer size. We had to read a lot of times to get the data. The first time, we got 17K-ish, and then 65K after that. We get 65K, 65K, then 32K. You can see you can't rely on that buffer size. So if you're saying content length divided by 65K, it's going to break here. Because we got a 32K, a 32K, a 32K, not even exactly 32K now that I'm looking at it, a 49,000, and then just kind of all over the place. But it does go up to 65K buffer, and I had to read a lot of times to get that entire multi-megabyte PDF file downloaded. So call receive, or let your callback be called and store that data, which you can put in a variable up here if you're, or here, put it in a variable with scope outside of this method, and collect all those bytes until you read content length number of bytes. And since you can assume only one client is uploading at a time, you can just assume that when you read data and you're buffering, that data is for the buffer and not for another user like requesting the HTML. Oh, that's not the lecture question. Don't answer that one. Yeah, we might test with a 46 megabyte image. You should be able to handle arbitrary size images. Roughly arbitrary. We're not going to send anything larger than your hard drive or something like that, but pretty arbitrary. You actually knew the answer to that question. And have a great day. I'll see you Friday.